This is Mr. Weideman, Lafayette High School pre-calculus class. This is our assignment for today on section 4.4 on logarithms. In addition to doing some example problems, I'm going to do some reteaching here. I really am not very satisfied with the way I taught how to convert logarithmic to exponential and exponential to logarithmic. If it makes sense to you, that's fine. If you recognize the basis, you recognize what's supposed to be the x value, the y value, and rearrange them accordingly. If you have that down, that's fine. I think this is much better because what we're going to do is we're going to use algebra, and we're going to use the algebraic properties of logarithms to show us how to do this. And it's really only one step, and you don't have to remember all those silly little rules about what goes where. All right, well, let's treat logarithms and exponentials like they are an algebraic operator, which they actually are. So the first thing I'm going to do is I'm going to take the logarithm of both sides of the equation. It's an algebraic operation. If I add something to one side of the equation, I have to add it to the other. If I take the square root of one side of the equation, I take the square root of the other. If I take the logarithm of one side of the equation, I have to take the logarithm of the other. The only thing that I want to pay attention to is I don't want to take just any old logarithm. I want to take a logarithm with a base that matches the base of my exponential function. So in this particular example, I want to take log base a of each side. When I take log base a of each side, now I am doing an inverse operation. Remember, logarithm base a and exponential base a are inverse operation, which means they sort of undo one another, and I'm just left over with the 2. All right, so those two things kind of wipe each other out. So that left-hand side of the equation simply turns into the number 2 log base a 1.6. I'm done. One line of algebra, and it's done. And I can do this in the reverse operation. Okay, here I have a logarithmic, and I want to convert it to exponential. And I think today in class, we did the little pigtail thingy, which is fine and cute, and all that other kind of good stuff. But let's see how this makes sense algebraically. So the algebraic operation I'm going to apply to both sides of the equation. Instead of taking the log of both sides of the equation, I'm going to take both sides of the equation and make it an exponent. Okay, exponent of base what? Let's make it exponent base pi. Okay, so what is my original function? I'll be right with you. My original function is log base pi x equal 1/2. So I'm going to raise both sides of the equation to exponent. Now, in my exponent, I want my base to be, in this case, pi, to match the base of the logarithm. And again, I'm doing inverse operation. Instead of taking the logarithm of an exponential, I'm taking an exponential and raising it to a logarithm. They're still inverses. They still cancel each other out. I still get the same answer as the little pigtail method. But I'm using the algebraic properties of logarithms to do such. Okay, let's take a look at another example. All right, I need to evaluate this without a calculator. Okay, so how am I going to do that? First thing I want to do is I want to match bases, which is the strategy that we learned yesterday. Log base 5, and then I want an exponential base 5. So what I'm going to do is I'm going to take this 25, and I know that's the same thing as 5 squared. Cube root is the same thing as 1/3 power. So now what have I done? I've changed the cube root of 25 into an expression, an exponential expression with base 5. Now what am I doing? I'm taking log base 5 of an exponential base 5, inverse operations. They'll wipe each other out. Before I do that, let's do the power rule. I'm going to take the 2 and the 1/3, so I have 5 to 2/3 power. Let's use the inverse property of logarithms and exponents, and then I get my final answer. One last topic that I didn't have time for today, and I want to take a look at some special logarithmics, and I also want to talk about the domains of logarithmic functions. All right, very important topic. Well, the domain of a logarithmic function is the range of an exponential function. Remember that they're inverses, and vice versa. So the range of an exponential function, which is y greater than 0, becomes the domain of the logarithmic x greater than 0. Why does this happen? Well, if you remember, in an exponential, y equals 0 was a horizontal asymptote. Now, in the inverse, the logarithmic, the y-axis becomes a vertical asymptote. Okay, and there's some special logarithms that we need to talk about, and this will wrap this up. Base e. Now, this logarithm has a very unusual base, 2.72. And we remember from our discussions yesterday that 2.72 is the same thing as e. It's an irrational magic number. And instead of going log base e, we just call it the natural log. But it's very important that you remember when you're doing stuff, these guys are identical. Saying this and saying this and saying this are the same thing. Remember, I can make a log base anything. All right, last but not least, what if it's no base is written at all? And this is most commonly what you see, and we call this the common log. And by default, it is base 10 when we don't write a base at all. Okay, so when you see something without a base, you automatically assume it has a base 10, and then go do your conversions and your calculations accordingly using 10. Just like over here, we do our calculations and whatnot using e. Okay, I hope this helps. Have a good weekend, and we'll do some examples and warm up on Monday.